Good day everyone, welcome to the continuation of our discussion on the topic differentiation. Today we'll be treating the general formula of differentiation and differentiation of polynomial function. Let us consider an equation y equals to x to the power of n. Now finding the derivative is the first principle. We know that for every change in y there will be a corresponding change in s. So adding our change in y and change in s, y plus data y will be equals to, in bracket, s plus data s raised to the power of n. Now our next step is to expand the bracket s plus data s raised to the power of n. Now expanding this using binomial expansion, y plus data y will be equals to s to the power of n plus n s to the power of n minus 1 data s plus n in bracket n minus 1 s to the power of n minus 2 data s square divided by 2 factorial plus it goes on and on to plus data s raised to the power of n. The next step is to subtract y from the left hand side and s to the power of n from the right hand side. Doing so, our equation becomes y plus data y minus y will be equals to s square plus n s to the power of n minus 1 data s plus n in bracket n minus 1 n raised to the power of n minus 2 data s square divided by 2 factorial plus it goes on and on to data s raised to the power of n minus s to the power of n. Simplifying further, y plus data y minus y will become data y because y and minus y will cancel out to be equals to n s to the power of n minus 1 data s plus n in bracket n minus 1 s to the power of n minus 2 data s square divided by 2 factorial plus it goes on and on to plus data s raised to the power of n. The next step is to divide both sides by data s to get data y over data s. Doing so, data y over data s will be equals to n s to the power of n minus 1 plus n in bracket n minus 1 s to the power of n minus 2 data s square divided by 2 factorial data s plus it goes on and on to data s raised to the power of n minus 1. At this point, we find our dy over ds, which is equals to the limiting value of data y over data s as data s tends to 0. This will be equals to the limiting value of n s to the power of n minus 1 plus n in bracket n minus 1 s to the power of n minus 2 data s square divided by 2 factorial data s plus it goes on and on to data s to the power of n minus 1. When as data s tends to 0, data s becomes 0. So if putting data s as 0 in our expression, all the parts of data s equate to 0 and we are left with just ns raised to the power of n minus 1. So therefore dy over ds is equals to ns raised to the power of n minus 1. This is the general formula of differentiation. It states that if you have an equation y equals to s to the power of n or a function fs equals to s to the power of n, dy over ds will be equals to ns to the power of n minus 1. We've deduced the general formula of differentiation, which states that for every function y equals to s to the power of n, dy over ds will be equals to ns raised to the power of n minus 1. So we'll be using this formula to attempt the questions on the board. Now for our solution, number 1 says that y equals to s raised to the power of 3. Recalling that for any function, dy over ds will be equals to ns raised to the power of n minus 1. So therefore dy over ds will be equals to 3s raised to the power of 3 minus 1, which is equals to 3s squared. Similarly for number 2, y equals to 3s raised to the power of 5. Now we have a constant in front of s. Normally we don't differentiate those constants, we just multiply as usual. So our dy over ds will be equals to 5 times 3 times s to the power of 5 minus 1, which is equals to 15s raised to the power of 4. Example 3 says that y equals to minus 12s raised to the power of 6. Similarly, dy over ds will be equals to, we are multiplying by our power 6, so it will be 6 times minus 12 times x to the power of, we are reducing 1 from the power, 6 minus 1, which will be equals to minus 72s raised to the power of 5. Our next example says that s equals to 3t raised to the power of 4. We are going to do the same thing even though the variables are different. So the s over the t will be equals to, we are multiplying by the power, 3 times 4 times t raised to the power of 4 minus 1, which is equals to 12t raised to the power of 3. Our example 5 states that y equals to as, and we are told that a is a constant, and like I said earlier, we are not going to be differentiating the constant, so it becomes the y over the s will be s to the power of 1 minus 1, which will be equals to a s to the power of 0, which is equals to a. Now number 6 say y equals to a. If you are differentiating a constant, the answer is 0 for any constant. As long as there is no variable attached to it, the answer is 0. So the y over the s will be equals to 0. Next, we are going to be discussing differentiation of polynomial function. Basically, when we differentiate polynomial function, what we do is that we differentiate each component using the general formula individually, taking note of the signs. We have 4 examples here we are going to attempt. Example 1 states that let y be equals to 4s squared minus 3s plus 5. As explained earlier, we are going to be differentiating 4s squared separately, minus 3s separately, and 4. So therefore, the y over the s will be equals to, when we differentiate 4s squared, we multiply it by 2 and we remove 1 from the power, it becomes 8s, minus, when we differentiate 2s, as proven earlier, it will be 3, and when we differentiate a constant, it will be equal to 0. So our dy over dx will be equals to 8s minus 3. Number 2, let y be equals to 3s to the power of 3 plus 2 divided by s squared plus 5. Simplifying the fraction, it becomes y equals to 3s to the power of 3 plus 2s to the power of minus 2 plus 5. Now differentiating each component separately, if we differentiate 3s to the power of 3, it becomes 9s squared, minus, when we differentiate 2s to the power of minus 2, it becomes minus 4 to the power of s minus 1. Therefore, it will be equals to 9s squared minus 4 over s. So our dy over dx is equals to 9s squared minus 4 over s. Number 3, let y be equals to 4s to the power of 4 minus 3s divided by 3. We first have to simplify the right hand side. It becomes 4s to the power of 4 divided by s minus 3s divided by s. So this will become y equals to 4s to the power of 3 minus 3. Differentiating 4s to the power of 3 is going to give us 12s squared, because 3 times 4 is 12, and once we remove 1 from the power, it's remaining 2, so it will be 12s squared. Now for differentiating minus 3, it becomes 0, because whenever we differentiate a constant, it's 0. And number 4 says that let y be equals to 2s in bracket s plus 5. The first thing we are going to do is expand our bracket, so it becomes y equals to 2s times s is s 2s squared, and 2s times 5 will be equals to 10s. So y will be equals to 2s squared plus 10s. Differentiating this, the y over dx will be equals to, if we differentiate 2s squared, it's going to give us 4s, because 2 times 2 is 4, and once we remove 1 from the power, 2 minus 1, we are left with s. And once we differentiate 10s, it will be equals to 10. We have some exercise for you to try your hands on. For more insight on this topic, you can check our Hidden Facts Further Mathematics textbook, chapter 29. You can get the hard copy, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.